Today, but that's just good afternoon. My name is Dr. Jim Lanny, and I'm going to give a little presentation about how to analyze quality improvement in evidence-based practice project data and get into the tool a bit. And I'm here to answer your questions. So, with that being said, you can use both the chat and the Q&A. On the line two is Ashley to help faculty with trials, demos, courseware, anything of that sort. Samantha for any students on the call. She can help with setting up 20-minute free consults. And Melissa for everything else. Um, okay, so Melissa, anything else we have to, you can
I
see my
think that's
screen?
it.
All
Yeah, we can
right,
see.
pardon?
Yes, we can see your screen.
Perfect. Okay. All righty. I like to do that before we get started. Otherwise, I get in 20 minutes. I'm saying, are we supposed to see something? And so, yes. Okay. I am curious, how many students, how many faculty we have on the line here? If you throw that into the chat, I will curate the presentation a little bit. So if you want to throw that into the chat or into the Q&A, that would be great. Let me see here if I can open up the Q&A. One faculty, one PhD student here. Okay. Hi there, Delete. Uh, all right, faculty, good. Nice to see you. All right, students. Okay. So far we have a kind of a mix of both. Um, at any point, put questions in. Um, again, this is for you and your particular question. So I'm going to do some preliminary kind of overview, and then I'll stop for questions and then get into things. They have access to the tool, Melissa.
Yes, they'll have access to the tool with that login link, and it was emailed to everyone before too.
Excellent. All righty. So let's get to this. So I'm going to go over, PICO questions and how they relate to data plans, levels of measurement. I'll be brief, but everyone needs to know that. Um, how study aims really filter into statistical language, which really drives the data plan, and then choosing the right data plan. So those are really important things. Setting up the data. Most DNPs are doing paired t-tests. I should look at the research, but last look, it was like 80% are doing paired t-tests. People do proportion tests and so forth, but I want to touch on clinical and statistical significance. Not that people talk about clinical significance, but I think it's worth mentioning, particularly when you're out there in the world. Um, I want to share that the tool offers data cleaning and discussion drafts. Those are new things. The data cleaning wizard came out of probably a demo or a webinar like this that about 80% or 90% of a results chapter is actually cleaning the data. As Ashley and I have done, we've banged out analyses in 41 seconds in APA format interpreted. So the data cleaning is necessary. The discussion draft is a recent advent of the tool where your actual results are now put into context with literature and not only talking about um, the findings themselves, but also the theoretical and practical implications of your findings, future research ideas, limitations based on your data. That's a real help. And then we'll do the demo. Okay, so everyone's kind of familiar with PICO questions, but at the end of the day, what we really want to know is really just talking about the variables themselves. I mean, even when we talk about the intervention, that's not part of the analysis. That's the results or the data is impacted by that, hopefully. But we really want to kind of know, hey, did people change in knowledge from pre to post? Are there differences on some ratios of falls given some intervention? Things of that sort, okay? The key part with the data analysis plan, which is a lot of what I do, which is making sure that the right data plan is done, is identified and discussed, like assumptions thereof, and the level of measurement of your variables. Those are critical things. I won't say too often, but often enough, students are through their proposal without a clean data plan. And then when I hear, well, my advisor may want different things, I'm like, let's stop. Let's talk about the data plan, because a clean data plan that's approved is easy to execute on very often. Having no data plan or a fuzzy data plan just leads to problems and will lead you to have longer time in the program. So it's imperative most of the time to have a clean data plan and have advisors agree with that strategy or make suggestions to that strategy. That's the time to do it. Before one composite score is created, you should have a plan what you're going to do. People don't build houses by starting to cut wood. People build houses by having clear drawings and a clean plan. Any of those change orders that happen, you want to do that in the planning stage. You do not want to do it when you start cutting wood, okay, or framing a roof. You want to have that plan really clear. Same analogy of architecture comes over to conducting a results chapter. Levels of measurement are critical to know. There's only 3 of them. And the importance of that is that many of the tests are only allow certain levels of measurement. So if you're doing a paired t-test, you better have a scale variable. So that's the importance of knowing it. So that's intimately drives the statistical plan. So you need to know nominal is name only in Latin, and we're just kind of categorizing things in groups: Republican, Democrat, male, female, treatment control, whatever. There's no hierarchy to be had. I got a blue block, red block, green block. They're just different color blocks, okay? Ordinal has both the names, okay, as well as order. So horse comes in first, second horse comes in the nose later, third horse comes in 3 minutes later, okay? There's no equal intervals between time or equal intervals in volume or things of that sort, but they are ordered. Very often that comes up in age ranges, 20 to 29, 30 to 39, but then you have 40 plus. Well, that's kind of a longer, wider range there. So you should be careful about that and just make sure that you have the correct intention there when you make up questions. Satisfaction, I mean, being careful to say pain level, satisfaction levels, okay? So what that means is that all of those levels from, no pain to a little pain may be a different range than from little pain to a lot of pain. Scale, in scale, I mean continuous level variables, I mean ratio level variables, I mean interval level variables. I'm all bucketing those terms, using them synonymously because it doesn't make a difference when it comes to the data analysis plan, but I'm bucketing those as scale. And scale level variables have the above 2 characteristics. That is to say, they have a name, 1 inch, 2 inch, 3 inch. They have an order, 1 inch, 2 inch, 3 inch. Okay, but they also have equal intervals in between. So I can look from 1 inch to 2 inch is the same distance as 36 inches to 37 inches. Okay, so that's the levels of measurement there. There's a question about Likert type items. Lots of people use Likert type items. Different instruments use Likert type items. So it's worth a quick conversation about that. Very often, a discussion happens that I have a 5-point Likert scale, and my prof or my journal wants me to treat it as ordinal. The literature says not so quick, that if you have 3 or 4 point scales, you should keep that as ordinal for one item. If you have 5 to 7 point scales, you can turn those into scale level variables. Okay. Once you are starting to average Likert type items, be it 3, be it 4, be it 5 or 7, once you average them or sum them, we are now in scale land, okay? And if you think about a test you took as a kid, you got it correct or incorrect, that's a nominal level variable. I got question 1 correct, I got it incorrect. But once I say, how many did you get out of that 10-point question? I got 8 correct. That is clearly a scale variable. So just know that once you start that process of composite averages, it's kind of redundant, but some scores, we're treating those as scale. And by the way, there's a lot more intuitiveness in scale level variables. So, people understand what a mean is or what an average is. And it's just easier to work with and to explain. So, statistical language is important. It's not always followed. Some people talk about relationships and talk about regressions in the same breath. I do not typically. So there's 3 kind of major buckets of how study aims can be phrased in statistical language. And one is differences. Are there differences on A by B? Are there differences in runtime by, sex, male or female? Are there differences in knowledge from pre to post test or something from pre to post test? Okay. So differences is a good term to put in there. Relationships is just relating 2 variables. Typically, it's bivariate, so we're just looking at relationship between 2 variables, and you can use the relationship language, okay? And people will know typically what that means. Prediction, the synonyms for that. Does these variables impact that? Does it predict that? We're really kind of in regression land there, which is fine. But just know that the language of differences, relationships, and prediction evoke different types of statistical analysis down the road. Here's a quick cheat sheet for different statistical tests based on the kind of data you're looking at and how many groups and how many levels of measurement. So if you have a pre-post test paired or matched, what does that mean? That means that I can identify person ID 1 at pre-test and I can match them or pair them with ID 1 at post-test. So if you're doing pre-post designs, make sure that you can match them. So what do people say? People say, well, it's anonymous or it's confident. It doesn't have them make up their mother's birth date plus their dog's name or something, okay? You don't have to be able to identify them to be able to have some kind of a code or key that you can match these folks. And the level of measurement is scale, and it's just 2 time points, pre to post, something of that sort, okay? If your pre-post is ordinal level at 2 time points, you're doing a Wilcoxon. Typically, these kind of go hand in hand. So typically, and maybe I can show this, that if you're running a pair t-test, that these have assumptions, and if an assumption is violated, we wind up doing the Wilcoxon, okay, which is looking at the same kind of thing. Are there differences pre to post? However, it's without the assumption. Okay. Group comparisons, two groups, treatment intervention, level of measurement of scale, knowledge, number of falls or whatever. Okay. Um, Independent t-test. Once you get into three or more groups, we're kind of in ANOVA land. ANOVAs and t-tests also have assumptions. Association is really, I should have just said relationship, but association can work, but relationship is better there. And if they're both nominal, we're in chi-square land. Um, if they're scale and scale, we're in correlation land. And prediction, we're clearly in regression land. I've only listed two regressions, but the key to regression, selecting the type of regression, is the outcome variable, the dependent variable, the outcome variable, the criterion level variable, again, all synonymous in my brain. And when that outcome variable is scale, we're in linear regression. Folks also talk about multiple linear regression, which just means that it's a linear regression that we have more than one predictor. And then the other very common kind of regression is a binary logistic regression or logistic regression. Again, doesn't matter the kind of predictors you have in either of these, but the key is that that outcome variable is binary in nature, disease, no disease, yes, no, live, die, whatever. Okay. And we do have a decision tree built into Intellectus. Since t-tests are so common, I thought I would have a slide that shows how to set that data up. You'll notice here, you'll notice here that the participants are always on rows, okay? I get messy data, and data's, all different kinds of ways, different sheets. You want one sheet with one participant on one row and their scores on one row. So for the paired t-test, you're going to need to know what nurse one's pre-test score was and what nurse one's post-test score was. Now that pre-test score may have been, 30 items to get to that pre-test, again, all on the same row, okay? And then I'm going to average or sum their scores and put that score on the same row and ditto for post-test. So that's a very, that is the way to set up a paired t-test data. For independent sample t-tests to the green here, again, participants are on rows, okay? The only difference here is that I have a new variable, a new column, a new variable called group, and I'm identifying which group they're in. In this particular example, it's intervention or control group, okay? But the key is one participant, one row, and then any of the other variables, be it a post-test score or some kind of a score, and then what group they're in. So I can look at differences on scores by group, okay? And I'm happy to talk about other data setups if there's an interest. Okay. I wanted to put in a quick slide because it doesn't really come up in these projects I see. So I'm kind of advocating for clinical significance at some level, at least to look at it. Oftentimes, the clinical significance, statistically known as an effect size, a correlation is an effect size, Cohen's d, that's associated with a t-test is an effect size, which is talking about the meaningfulness or the importance of this. And I'll say, necessary is the is the statistical side of the ledger, which is, hey, were there statistical differences, from pre to post, or statistical differences by group? And you'll get that p-value in this 0.05, came down from God, that somehow, that's not, I say that jokingly, but the truth is that's a made up number. That's kind of a standard, but I have seen significant p-values of 0.06 or 0.10, depend upon your study. And they call it marginally significant or things of that sort. So it is not God-given. That it really is just kind of the standard that science or scientists have, or researchers have kind of said that p-value that is finding differences by chance 5 times out of 100 was a critical threshold to say we're going to be significant or not significant on this test. Clinical significance, again, is the importance of things, and I have a quick slide on that. So there's 3 kind of cases here. I guess there's 4 with nothing's significant or important, but for simplicity, things can be statistically significant but not clinically significant. You found a statistical difference in systolic blood pressure, but it doesn't really reduce cardiovascular events. Statistically important, but not clinically important. Clinically significant, but not statistically. Falls are reduced by 30%, but didn't reach the threshold of statistical significance. This happens a lot in DNP projects, by the way, or other kinds of projects where the sample size is really small. I've seen studies with 5 people, and sometimes it's really challenging to get large samples. So all the more important to actually look at the clinical significance of it, because maybe fall rates were reduced by 30%. That means a heck of a lot to those 30% of patients that are not falling. By the way, major problem, right? A major problem in hospitals, major problem for their financial, and major problems for the patients, of course. And then, ideally we have both something that's clinically significant and statistically significant. Readmission rates are down and it happens to be statistically significant. Great. So you'll notice in the, again, in t-tests or ANOVAs or regressions or correlations, there are effect sizes. So report those. And in our discussion draft, we do speak to that, okay? In addition to the statistical significance. So I just want to highlight that for you, that it's worth thinking about and talking about. As I mentioned, we have a data cleaning wizard. It does lots of stuff, particularly for data raw output from Qualtrics. Often I have several rows of headers. It's question 1. What is your sex? 1 is a male, 2 is a female. Then it gets you your data. In Intellectus, really, you just need the variable name, hopefully concise, but not those other rows. And it does other things to help manage that, I won't say arduous task, but data management task. Discussion draft, again, it's a great starting place. When we just say that you can write your discussion draft by yourself and then kind of look to see what the discussion draft complements. So you can get the draft first and edit it. The preferred way is to actually test your brain first and see what you come up with, and then look at that discussion draft. I think faculty would be happier knowing that you're critically thinking first. And there's literature that says that if you do that first, okay, you apply your brain first, and then do it, there's more neural activity going on than the other way around. Okay. So for your brain's sake, it's got to work harder, but the benefits are there. Okay. So let's hop into the demo. Let's upload some data, and then let's take it from there. And maybe I will, while this is happening, maybe I will answer some questions here. Sending recordings. Hello. Hi there. Okay. No immediate questions. Is there? I kind of went through that. It seemed like 3 seconds for me, but it did take 26 minutes. Are there any questions about anything that I just spoke about? What was not clear or can use another round? Let me see if there's other questions down here. Isn't there an assumption for the paired t-test are only used if the data is normally distributed, or is that old stuff? That is not old stuff. So we'll get into that. So let me just open up a data set here. Well, let me just give an overview of this thing first. So here, the top 4 buttons are kind of analysis buttons and visualization and management buttons. These buttons down here are functions when you're in the planning stages. And maybe we'll talk about that real briefly. But I'll get back to your question about the, no, I won't say nothing seems to die in statistics, but assumptions are definitely not one of them, okay? Okay. So it's a web-based tool. Many of you probably have it in your LMS, behind your LMS. For those that don't, go get it, okay? So anyway, it's web-based. There's no updating to this thing. Decision trees kind of speak to this prediction differences, okay? That I can say I want to predict an outcome. What matters is the outcome variable. We could probably say dependent variable there. So if I'm doing a scale, I'm doing a linear regression, okay? Once you know you're doing a linear regression, you should have the data plans for that. And by selecting the data plan templates and the analysis that was just determined, you can see some of the assumptions. This is downloadable, editable, and referenced, okay, that you can talk about the assumptions of the test you're going to conduct. And to the individual that just mentioned this, so even with a paired t-test up here, that we do talk about the assumption of normality and looking at the Shapiro-Wilk test. Okay. Also, we have not talked about this, but it's critically important, which is once you know the test and once you know the assumptions of the test, you should be documenting what your desired sample size is. And that sample size is called a power analysis in our projects, journals, whatever. And you can just select the test. And there's different sample sizes for different effects. Briefly, if it's difficult to detect, if there's a small effect from some pre to post test, you need a large sample to detect that. Conversely, if you have a large effect, okay, all right, you need a smaller amount of participants to detect that. If you know nothing, you could probably just go with a medium effect size. I think that flies for lots of folks. The technical way, so that's a practical thing, okay? The technical way of doing that is looking at other studies with your variables of interest and noticing whether or not the analyses resulted in small, medium, or large effects. The other practical issue is that, hey, gosh, my studies that I looked at identified small effects, but there's no way I'm going to get 199 people. So it's a conversation. Medium effects is a good place to aim for. Again, I've seen studies with as few as 5 people. By the way, you can also use t-tests and so forth, even with small samples. I have seen normality, crazy as it is, with small sample sizes. So the idea that I've heard is I must use a Wilcoxon because of my small sample size. That may well be what we turn out doing, but the fact is that you can run that t-test anyway, see what that result is, and then take it from there. Okay. Okay, so that's a priori kind of business methodology, IRB stuff. The to get into it, if people have projects, send them along. The projects, this is a place where you can upload your data from typically a CSV or Excel. You can paste data from your Excel file right in. Have just the variable name and the data underneath it. No code book needed. You don't need 1 for males, 2 for females. Just put male or female. And then for faculty online, we do have curated nursing competency-based courses that go hand in hand with Intellectus. And so the example data sets are found here, and you can see some of these hospital kind of courseware. But at the moment, I'll just grab this. Here I have a simple data set. I've tried to have an ordinal level group here, and you can see that it's ordinal because it's at 51 or older. We have kind of straight up nominal level variables, different kinds of movies, different kinds of fruit, and then some other scale level variables like what is your actual GPA and how many hours of sleep did you have on average last week or last night. You can manage data here. I'm not going through the data cleaning wizard, but you can do similar kind of data management here. Typically, you're going to be in a variable calculator where you're creating a composite score from your Likert type items on some validated instrument. You should use validated instruments for many reasons, 2 of which are that if you create your own scale, how do you know that it's valid? You wind up going down another rabbit hole of validating your instrument when in fact you just want to know what their knowledge is. Okay, so I would say to adapt an instrument that's already existing is a better road to go down than creating your own instrument. By the way, students that are on the call, I often say, how is it possible that you're in a doc program and no one on the planet of all time has ever created an instrument they validated, but you're going to do that in your project? Doesn't make sense. I would rethink that. So again, use validated instruments that are published. The other quick thing is when it comes to our discussion draft, it's going to be helpful to have an actual document, literature to go back to compare and contrast with your data. So that's another good reason to have validated instruments. So variable calculator is one thing. Certainly downloading your data. After you can create composite scores, for example, or average scores, you want that data, okay, in a CSV. Our servers are all backed up, but I like to have things on my desktop as well, a little old-fashioned that way. During my dissertation, I had that thumb drive under my pillow. I said, if I ever lose this data, I'm gonna, kill myself. The data is just gold, and you just don't want to lose it. and you don't want to lose all the work that you've done to create and manage that data as well. There's different types of plots that can be had. We've made it very simple to look at these things. You'll notice the icons, by the way, of scale, ordinal, and nominal. I also note that in the data management and in the plots and in the analyses, there's a helpful 2 or 3 minute video. There's probably 100 of them. So just know that videos are there and icons to help you make sure that the right level, well, only that level of measurement can be entered. But if you think you have GPA and you have ABCD and it's nominal, you're not going to be able to show that. So if your variables do not show up there, looking at the level of measurement is going to be the key. And here we can see pre-post differences on GPA by different age groups, where they look pretty different in the beginning and kind of coalescing at the end. Okay. For the analyses, lots of options here, all of the correlations common. Proportion tests, later on I'll be looking at proportions of, malpractice between, one group of practitioners versus another. 2 proportion z-tests of our friends there. We have t-tests, mostly paired and independent are the common ones. ANOVAs, regressions, as I mentioned, non-parametrics, which is the chi-square, which has the Wilcoxon, and there's other advanced analyses. There's structural equation modeling to be had, and other advanced analyses, which presume that you have some other knowledge about regression before you get into mediation, hence the advanced category name there. The other thing I'll mention, and I'll do that right now. You should always run descriptives on your variables. And the caveat is you should run descriptives and then read what you did. For a long time, I didn't do descriptives. And then I had to go back after I found out there was an outlier, or I put in 5.5 when it should have been a 5. We're human, we make data entry errors, but this is the catch to that. So this is the part of it, to run them. The other part is to read them. So wouldn't have been the first time that I've actually run analyses that, do descriptives, do the paired t. Wait, time out. We have to run descriptives and then read the descriptives. So you want to look to see if GPA is ranging from 1 to 4, okay, or 0 to 4, you want to make sure that max value is not greater than 4. Ditto for sleep. If somebody's sleeping 99 hours, okay, that's probably a data entry error. So you want to kind of check that out. For those of you who grew up with SPSS, some of the faculty online, we've come a long way, baby. For those that don't know any different, having APA tables spit out and some kind of quick description of that's a revolution. APA tables with scrollovers to help you figure out what these terms and symbols mean, it's just not out there, aside from Intellectus. So know that you're getting streamlined products here. It wasn't always that way. Okay, so I'm going to do a quick pair t-test. You click on the variables. Does anybody want to tell me why we're doing a paired t-test to look at GPA pre to post? Any takers there? Same times, sometimes? Sometimes. I'm not sure. Okay. So you should know that the paired sample t-test is the appropriate test when we're looking at the same people pre to post on a scale variable. That's the reason to do that. I should highlight that we also can look at the scale variables. That's a clue. That there's the video to help you figure out how to do this. For faculty, I'll just say that for all these tests, there's often options to be had here. You can do different kinds of tests here. So just know that that's there, okay? So looking for differences pre to post after some educational intervention, the semester ends, and then hit calculate. So for all of the tests over here, there's a little kind of an introduction. Any of the assumptions that are part of that test are identified, normality assumption. The test is identified to test that assumption. The test is then conducted, and then the test is then interpreted. Okay. So that gets back to the earlier question. So yes, for you definitely, so 100% you have to look at those assumptions. And then here, this is just a way of reporting it. You should edit this document, but the t-test was significant. Most DNPs are not using null hypotheses, so you just dump that. Here we have an APA table that, since we know it's significant, we can assume that that post-test, is obviously greater than the pre-test. There's a probability level, which is technically the chance of getting that t-value is the probability of getting that t-value by chance. That D, anybody want to guess what that is? Anybody? We got enough people on the line here. Going once, going twice. All right, so that's the effect size. That's the clinical significance part. Often in these, not often, in t-test and ANOVAs, Cohen's D, Jacob Cohen from the 80s. So here we are moving on 50 years. Back to old stuff. Nope. Same old Cohen's D. No one's improved upon it. Okay. So that is the effect size. Okay. So that's saying that it's statistically different and that it's clinically important or important. Okay. Because the assumption was violated up here, okay, we in the tool enable the non-parametric test, which is just a fancy way of a different test without assumptions here. It happens to be the Wilcoxon test. We can see how the Wilcoxon is reported. We can see that there are significant differences. We're looking at the medians here, or medians and ranked scores. It's tougher to talk about ranked scores. You kind of got to do a little thinking there about what that means to rank them. It's a conversation that I've had, happy to have again. So just know that that box plot is sharing what the ranks are. Because you could say, well, wait a second, what is this rank of 15 on GPA? GPAs only went from 1 to 4, but so ranking is a different process. And then once you've done your analyses, you can download your data, your results rather. And in that, if I can move that over, you can see, here, we have a nice draft going. So our descriptives, our t-test, our Wilcoxon, APA style references for the in-text citations. Also, we include a curated glossary. We should be testing you on this. What do these things indicate? So there is a glossary of terms and symbols curated to the particular test that you ran. Okay. Just to share that that's going on. And then, of course, we have a discussion draft. So once you click on discussion draft, what it's doing is looking at your output, your results document, and identifying each of those variables. And then, so you have to put in a discussion draft name. You should add your research problem or study aim or research question. Age group has figured that out. Post GPA, grade point, it figured that out. But this may be different. So this may not be hours of sleep obtained during the week, during the night, last month. So you want to be very specific here. Sometimes I look at burnout scales, and EE is employee engagement when it should be emotional exhaustion. So the AI has done the best job it can to figure out what those variables are. Okay, so and then once you do that, you have to confirm, hey, gosh, you verified the study aims, inaccuracies can happen, and so forth. Okay, and then you'll get a nice output from that. Probably have an example of that. Sorry, I should have put it up top. This was on on Matchlock's burnout scale. And if you go to those analyses and go to discussion draft and view that draft, you can see kind of the output that you get with some intro, some summary of findings, some interpretation of the findings, theoretical and practical implications of your findings, limitations, recommendations, and conclusion and references all have to be vetted. AIs are getting better and better and better. Still got to check out the DOIs, and they're wrong sometimes. Less so than when I first started this process, but I generated recently maybe 40 references, and only one had the wrong DOI. Used to be 15%. So they're definitely on that accuracy path. Let's see, anybody share a project here? I know we're getting close to the end. Let me refresh this.
You can also raise your hand if you have questions and we can unmute you.
Any questions, any place where you're stuck with data analysis? Don't be shy. Since I have a moment, I will shamelessly say that, oops, didn't want to do that. I'll say that the tool, the Intellectus 360 also has not only the statistics app, but we also have a lit review app. We have a qualitative app, and we have courses, which are, is that down below here? Melissa, to show the
Within
courses.
each solution, there's a courses one. So
Got it. And then there's the curriculum for qualitative or for quantitative. You kind of see what that looks like. Again, behind your LMS, competency-based with quizzes, go back to your grade book, different lessons to be had that you can curate for your class.
and there's a question in the chat.
Okay, great. Thank you. Should I aggregate data, use mostly independent t-tests? Okay, so the t-test, so why would you use the t-test? Right? So it's not about the data aggregation. The many DNP products advise participants that answer pre-test are not the same people at post-test. Okay, so good question. So let's go back. Let me get this out of the way. So when you have the same people that take the pre and post, we are impaired. So you have, instead of group, you have not intervention control. You have some people did the pre-test, other people did the post-test. So yes, you are doing an independent samples t-test there. Okay. So yes, so you have different groups there. Once you have different groups, you're in an overland, you're in t-test land. Other questions? I should show this slide here. I should give contact information. Again, Samantha is here for students, Ashley for faculty, Melissa for catch-all, contact phone number, the website where you can access these tools, um, QR codes for students or faculty, a free 20-minute to kind of get you in the right direction. Um, and anyway, I hope this was helpful. The last breath for questions. I don't see any. Thank you all for joining. We will send you the video and we will also share upcoming webinars as well. So with that, I'll say thank you. Thanks for your attention. Stay safe and happy, and we'll see you next time.